Hi, I'm Matt with Schematical, and today we're talking about how to use Terraform to set up ECS services on AWS. That's the Elastic Container Services. Additionally, as bonus content, we're also going to be talking about how you can route traffic from an ALB, an application load balancer, through the target groups to the ECS services using Terraform. So before we get into all that, we should talk about what ECS is. So ECS is AWS's main solution for running Docker containers for an always-on service. So like a RESTful API that's always on, or possibly a background worker that is so heavily used that it needs to be always on as well. If you don't know what Docker is, this video is probably a tad advanced for you. So if you want me to make a video about that, leave a comment and I will do my best. Let's take a look at how it all works together. If it's not a worker, if it needs web traffic, then the internet requests will get routed to your ALB. You'll create an ALB, an application load balancer, and that application load balancer will most likely have at least two listeners, one for 443 HTTP and one for HTTPS, and then it will take that and route it to a target group based on various rules you set up, where it will then route and distribute that traffic evenly across various Docker containers running on your ECS services. So this represents one service that could have multiple Docker containers. Technically, they're called tasks in ECS, so you can have a task with multiple containers on it. I'll get more into that later. It'll do its business, and then its response will get routed back. So traffic comes in, ALB, to the ECS task, back to the ALB, and back to the internet. Here, I've got it set up so you have separate ALBs for the two ECS services, but I'm going to show you how we can actually get away with just one and save even more money. So without further ado, let's get into the code. Let's start out with the ALB. So you can go to the EC2 console, load balancers, and select your load balancer there. In here, you can see that we have two listeners here. One for port 80 for HTTP traffic and one for port 443 for HTTPS traffic. You can see here we're using a schematical.com ACM cert. Now, one thing to note here is it's not just schematical.com. I'm actually sharing one ACM cert across multiple hosts here in case I wanted to route traffic from any of these hosts to that load balancer. And remember, that's because we can share load balancers across multiple ECS services now. And in here, I've got two rules. So it's important to note that we've got our base rule. So if I just go to the load balancer's raw DNS without the host name there, it has this fixed response content. That corresponds with here, where you can see if there isn't a rule that hits up here, it will hit this fixed response content and respond with a 200. Then if you see here, if I hit ship-or-get-off-the-pot.com, which you're going to have to take my word for it, is pointed at that same load balancer, it actually routes it to my Express app and it responds. And that's because it hits this rule that forwards it to this target group here. So this target group right now, you can see is associated with that load balancer, and it has one healthy running target, and that target is our one ECS task running in our ECS service. So let's jump over to the AWS ECS service now and look at our cluster 1 here, and we can see we have one service here currently. This service has one task running currently. That task, we can look at its configuration here and see all sorts of interesting details here. We can look at the operating system, the CPU we've got there. We're using Fargate, so Fargate doesn't require us to provision stuff ahead of time. It basically just boots things up. Hi, Teeling. It's Teeling. You want to up on my lap, of course, right in the middle of a video. Fargate can basically boot up without having to boot up EC2 instances or host it on some other platform. It basically magically gets hosted, just boots up wherever. It's a really nice setup. Not technically the most cost efficient, but still pretty good. It's really nice for scaling. You can see I've only got the one container here, and we can look at the, all sorts of details in here. But this is not a comprehensive ECS. Dude, Teeling. Don't need the microphone, man. This is not a comprehensive ECS video. This is how to use Terraform on ECS. So let's get to the Terraform part of things. I'm not sure. Oh my God. If you'd like to see a more comprehensive video on ECS and how it works together with ALBs or any of that stuff, go ahead and leave a comment. I'll do my best to make a video about it then. So now jumping over to github.com/schematical/sc-terraform, I can go ahead and look at my modules here. And let's start with the ALB, since that's where we started before. Oh, you're going to be a little space heater on my lap, bud. So the first thing we want to do is give it a service name. So in my case, you call it Chaos Pixel Web Server, something of that nature. The second thing we're passing is an environment, so stage, dev, prod. Third, the region. Fourth, the VPC ID. I do have a module for that, so check out the video on VPCs, one of the building blocks to all my other stuff. The ACM cert ARN, you can actually boot that up in Terraform, which is fun, and it just takes a minute. You may have to run Terraform twice, and then it takes a public subnet mapping. So this needs to be in a public subnet so that traffic can reach it from the outside world. So that's all the variables we pass in. Then in the main part, we declare a load balancer, an application load balancer to be specific. It's got a security group, which we define right below it. So this is a security group. It allows all the traffic in the world to hit it on 80 or 443, and it can egress to basically anything because we kind of trust this thing. In the future, you could add more specific rules there, but right now, because of the way things boot up, it doesn't know the ECS service exists because the ECS service needs this to exist before it can reference it. So it can't know those IPs off the top of its head. So we're just going to let it egress to wherever. The AWS ALB listener is that thing listening on port 80 or 443. And it's got a default action of that fixed response content, which is if you don't pass in a host name it recognizes, it'll just default to that. I should probably change that to something more clever, huh? And then here we attach it to the AWS application load balancer, and we say port 80 protocol HTTP. Same thing here, 443, but we need an ACM cert ARN that will boot up outside of here. And I'll show you that when we get to the in action section, where I show you this thing in action. And the outputs are pretty simple. Security group ID, ALB ARN, ALB hosted zone ID, ALB DNS name, which you'll need to point your Route 53 records at, load balancer HTTP listener ARN, and load balancer HTTPS listener ARN. All right, let's jump over to the ECS service, and then I'll show you how we associate them with this third module here. So this is the second module. This takes in a service name, probably the same thing as the load balancer. Takes in a hosted zone, so schematical.com, shippergetoffthepot.com, etc., etc. And again, environment, region, all pretty standard, VPC ID, and an ECS cluster. So you're going to want to create an ECS cluster, probably in Terraform, and pass that in. So all of my prod services share one cluster there. Then the next one is private subnet mapping, so it knows which subnets it needs to boot up in, and you want them to be private. You don't want the whole world hitting your running Docker container and bypassing your load balancers and WAF and all that other stuff. WAF being AWS's firewall system. Your ingress security groups, so that is the security group that is exported from the ALB. We want to pass that into this so it knows what to allow in. The task CPUs is however many CPUs you want it to have access to times 1024. So in this case, we're doing 512 because we only want half a CPU. I don't think you can go smaller than that. If you want smaller than that, use a Lambda, I guess. I don't know. Task memory is 1024. I think that's as small as you can go. It's got to be twice the memory, or twice the CPU, if I remember correctly. The desired task count is how many tasks you want to run at once. Now, the cool thing is we can slap auto scaling on this thing after the fact, and it'll scale up and down accordingly, but that's a bit beyond the scope of this video. If you want to see more about that, leave a comment and request that video, and I'll do my best to get that to you. AWS Load Balance Target Group ARN, that is the target group that we haven't actually booted up yet. So I'll come back to that in a little bit. And then the ECR image URI, so you're going to have to boot up your ECR image repos separately from this before you get to this ECS service. And the container port, 80, pretty common. The reason it's 80 and not 443 is once you're past the load balancer will decrypt that traffic by the time it's a private subnet. So once it's in the private subnet, the internet can't hear it and sniff it, so it bounces around inside of there unencrypted. You could go 443, there's no reason you couldn't. That just slows things down slightly because it has to get decrypted again at the next point inside the task, and that's just a pain. All right, let's take a look at the main here. So at the top, we're defining the data of AWS caller identity. That's basically just so we can get our own AWS account ID. Then there's an AWS security group. So this is the security group that will assign to the ECS service that has the ingress rules of the ALB. You can see down here, we've got our container port, and it allows ingress from our ALB there because we pass that in, or we will pass that in a minute. You could also pass in other security groups if you wanted to, possibly your bastion. Same thing here, we're being pretty open on our egress rules, so we're just trusting that you're not going to put a Docker container in your own environment that's malicious. Don't do that. Then we've got an IAM role, which is important because your Docker ECS task will need to reach out and do various things on your behalf, okay? So the first of which is you'll need the task execution role policy, which allows you to basically execute the task. And then here, grab the secrets for your Docker task. So what environment secrets do you want to pass in? Don't hard code important passwords and credentials into your code base. Don't do that. Don't hard code in your infrastructure. Pass it in via Secrets Manager. It's what it's made for. Here, we boot up a Secrets Manager resource that you then can put as much information you want into. So I do like a giant JSON blob of all my credentials, put it in one Secret Manager entry, and then pass it in. That's the easiest way for this to work out of the box. If you want to attach more, be my guest. It's not that hard to do. Then we do a AWS CloudWatch log group, so that way we can write logs that we can then view. I should make this retention a variable, but you can go ahead and change this and fork this if you want. And we have AWS ECS task definitions here. So this basically defines all that compute needs here. Right now I'm hard-coded to Fargate because that's pretty much the easiest one to do. I can do others if you want. Jump on the Discord if you have any questions or want help with this. Additionally, I should take this time to tell you I do consult on this. So if you have questions, you get stuck, I have group coaching courses that I can work with you on where I can help you out. And I've got consulting products where you can engage me and I can help your team figure this stuff out as well. So reach me at schematical.com. All right, AWS ECS service. So here's where we're actually booting up the actual service here that will use that task definition to boot up as many EC tasks as you have designated. This deployment maximum minimum percent, I should probably make a variable again, but right now it wants at least half the tasks to be healthy. So say I have 4 tasks running and I want to deploy 4 more tasks, it'll only cut down to 2 tasks and then sub in 2 more tasks, make sure they're healthy, then drop down the last 2 remaining tasks from the first deployment out and put in 2 more. Additionally, we are using the ECS deployment controller. It works really nicely with my code pipeline scripts, my Terraform code pipeline module. So feel free to check out the video on that. The desired count is right here. The health check is at 60 seconds. Basically some more network stuff, and here's where we attach the load balancer. So the thing we haven't booted up yet is the target group stuff, which we will do in the ECS service association there. First, let's look at the outputs over here, which all we're outputting right now is the ECS task association IAM role. Now let's jump over to the final piece of the puzzle, which is the ALB ECS service association. So this ties all the ECS services to the ALBs. So you can have one ALB with multiple ECS services or multiple ALBs with each having their own ECS services, however you want to do it here. It can work either way. So you pass in a service name, probably the same as the other service names, a hosted zone ID that is a Route 53 hosted zone ID, a hosted zone name, so in this case schematical is the default. Don't try using that one because hopefully you don't have that one. An ENV, a region, all the standard stuff there. Subdomain, so it could be www.schematical.com, it could be any number of things, dev.schematical.com, etc. A VPC ID, which comes from the standard VPC module I have, and an ALB ARN. So all the next variables, all these here, are outputs from your ALB. So make sure those get passed in. Then you're going to want to put in a health check path. I use Heartbeat quite a bit. Hackers don't hack me on that. Container port right there, port 80. I actually could write rules to exclude that from being hit from the web. So if that's something you guys want me to lock down, leave a comment. All right, let's look at the main here. This is pretty short and sweet here. The ALB target group. So this will point specifically at your ECS service. Okay, this is very important. This is specific to just that one service here. And we've got a health check for it, so that's how we know if the service is healthy. Should we kill one of the tasks because it has become unhealthy? Probably because a memory leak is one of the most common things that happens. So don't write memory leaks. Try and work those memory leaks out of there before this. But AWS load balancer listener rule. So this is the rule that now listens for the host header of your subdomain and your hosted zone. dev.schematical.com, www.shippergetoffthepot.com, etc. Here is the same thing, but it is associated with the HTTPS rule. That one's HTTP, this one's HTTPS. Then down here, we boot up a Route 53 record that points that subdomain and hostname combination at the ALB hosted zone. So that way traffic that is going to get routed to this host eventually goes through your ALB that we booted up in step 1. And this outputs your target group ARN, and that is what gets passed back to the ECS service here. And that's what associates them all. Now let's take a look at this in action. This may or may not be open source at the time you read this, because I might move my projects somewhere else. But right now, my ever-growing Terraform projects folder has most of how my actual Terraform looks. And again, a disclaimer, this is not how I'd recommend doing environments and structuring this for my massive clients. Each one of my clients has their own workspace. But for my smaller projects, I don't bother with that because they're tiny. I wish schematical.com got that much traffic. Come to me, traffic. So recently, I moved all my shared stuff over to here. So stuff that might be used between multiple projects or microservices in the future is now in the shared folder here. And one of the things I boot up right away is that ACM certificate that we were talking about there. And so it covers multiple domains. I'm actually not using it for just the regular schematical.com. I'm actually using it for these two. But yeah, that is the first thing I did there. So we're going to come back to that. That then gets passed to the shippergetoffthepot.com project, along with an AWS or an IAM role for the ECS task execution role. The other thing that's important that's in here, it gets booted up, one for each environment, so one for prod, one for stage, etc., is the ALB here. So this ALB for each environment, prod, dev, etc., we boot up one ALB. And that takes the private or the public subnet mappings, so that way it can boot up in the public and the ACM cert and the VPC and all the usual stuff there. So look here in my main, kind of everything ties everything together. When I build up those shared resources, I pass them into each project as these as a local environment info right there. So you can see for prod here, we've got the shared ACM cert, which we booted up already, the ECS cluster, and then all the information for the shared ALB. So that all gets passed into this project, or microservice you could call it, of shippergetoffthepot.com as environment info. Then in here, now because of cost, again, I'm only running one environment here, but if I was running multiple environments like a dev and a stage, I define all of them here. So this will pull the entire module that's in this env folder, shippergetoffthepot.com/env, and it will initialize it. Again, most of the services I'm running, let's go ahead and look at schematical.com for example. I'm running both a prod and a dev environment. And that I can do that because these are just lambdas actually. They're not always on, so they don't cost me anything if no one's viewing it. So my dev isn't costing me an arm and a leg. But if I ran a dev for a blog that I rarely ever use, I don't think I've used in probably 8 years or more, it'd be kind of a waste. So I just run a prod here. Now the only thing besides this that you see that I'm booting up here is I'm creating this shippergetoffthepot.com resource here. So the only thing I'm creating in this file besides the prod environment is a Route 53 zone resource of shippergetoffthepot.com. So let's dive into this env template. So we're in the shippergetoffthepot.com/env. The variables, pretty much the same stuff we've seen back and forth. Let's just jump right into the main here. First thing we do is we boot up an ECR repository. So that ECR repository will hold all the images for our prod, dev, staging, if we were to have any of those, all in one, and just tag them as that. Additionally, you could do version tagging, which is another great option. I'd strongly recommend it. Then we go ahead and boot up our first module. The first module in this case is the target group. This is just a reference to the module. This is the ENV, production service name. I'm going to abbreviate the whole thing. VPC ID, hosted zone name, hosted zone ID, subdomain, ALB, ARN, all the stuff we've been talking about. Honestly, this is pretty simple stuff. It sounds more complicated than it is. Then we're going to pass in the prod env ship or get off the pot ECS service. So we're going to create that module. So here we're going to create the prod version of the ECS service, and that will take all the usual stuff, private subnet mappings, not public, as well as a reference to that load balancer target group, which came out of here, the ECS cluster, because that's where it's going to run, the security groups from the ALB, because the ALB will be talking to it, not the target group. It's target group's more of a reference, and the ECR image, which is from that repo we created at the top, as well as using the environment as the tag and container port 80. Then the final thing you'll see in here is a reference to my code pipeline, build pipeline scripts. So that is what builds it. And you can go ahead and watch that video. It's a separate video. And that's pretty much all of it. So that is my Terraform modules for ECS, connecting it to the ALB, all that fun stuff. If you had trouble following along, that's totally understandable. This one is a kind of a threefer. It's a tough one. So feel free to ping me on Discord. The link is in the show notes. That's where I usually lurk. Otherwise, feel free to leave a comment. That always helps. Like, share, subscribe, etc. I do consult on this stuff. Schematical.com. You can sign up for a consultation with me, or you can, if you're just like an aspiring developer that wants to train and sharpen your skills a little bit, jump in with my group coaching. I do group coach. I'm happy to help you there.